Board. Sorry. It's like you push one thing and one time. All right. Yesterday we talked about perimeter of stuff with straight lines. Today we're going to talk about, well, one very specific type of thing with not straight line. If you don't have a circle, you can do, there's formulas for the perimeter or perimeter of an ellipse or all of that, but sometimes it gets a little bit complicated. So I'm just gonna, all these things. Circumference is the distance around a closed. Essentially, circumference is the perimeter of a circle. Hopefully, terms you've heard before. The distance from the center to an edge is the radius. And the fun thing about a circle is, as long as the center is actually the center, regardless of whether you go down, up, left, right, or anything like that, the radii are all the same. That's in some course. Or am I thinking, oh no, it used to be in one of the old courses. It's in grade 10 or grade 9, inscribed and central angles and all that stuff. There might be some in Foundations 11. I honestly can't remember. But it's 8:40 on a Friday morning. The distance from one edge of the circle to the opposite edge passing, this is important, through the center. Diameter. And because it passes through the center, there's one radius and another. So the diameter is always going to be twice the radius, or the radius is going to be half of the diameter. When it comes to areas and volumes, we're gonna want to use the radius almost exclusively. I can't think of any spot where we would not use the radius. But come on. But with the circumference, sorry, we can use the diameter. For any circle, no matter how big or small, the ratio of the length of the circumference over the length of the diameter is always going to be the same. It's the wonderful Greek letter pi. It was figured out, I think Archimedes was the first guy to figure that out, but I could be totally off base. So if I rearrange this formula, if I move the diameter up, the circumference is pi times the diameter. But then I can put this up here. Most of the time you're going to see this written as 2 pi times the radius. Why did that just flash at me? Just like any formula we have, I'll probably give you one of these at some point on a test. The value of pi, because I'm a nerd, I think it's that much. I memorized 10 decimal places in a class in university because the professor was boring. Pi 1415926535897, yada yada yada. Pi is what is defined as an irrational number. Pi is going to go on forever and ever. And when we get back, there's a poster up above the door. I think this is like pi take. When it comes to numbers, pi takes the cake. And that whole poster is literally decimal places of pi. And it goes on and on forever, and it never stops. And it's super awesome and amazing. It's one of the most famous math numbers in the world, which is fun. So we're going to look at, just to reinforce the relationship between diameter and radius, we're going to look at some circumferences. Then we're going to look at, find the perimeter, which is the circumference of each shape. We can move that. Oh, look at that fun thing. Oh, apparently there's just those two. So if I go down here, this, because it goes all the way across, is the diameter. Change colors. So this tells us the diameter is 8 centimeters. The radius is half of the diameter. Do you have to write this down if you understand it? Not really, but I'm going to show you the whole thing. So the radius is the diameter divided by 2. 8 divided by 2 is 4 centimeters. So that's where we go with that one. This one we're given a radius. 12 meters. That is one big circle. I wonder what the radius of the circle on a hockey rink is. Because I'm sure it has to be a very specific number, so all hockey rinks are the same. Diameter is 2 times the radius, which is 2. There's 12 meters. 3, that is significantly larger than the size of a circle on a hockey rink, because 70, that's like 70 some odd feet, maybe 80 feet. 78 feet, 79 feet, that's bigger than a hockey rink. So far, so good. These circles, ironically, they're very similar, but the units are different because that's the fun way to do things. When we have a circle like this, we have to assume, there's the center. So this one has a radius of 4 meters. So if I'm just going to scoot back up here, I'm given the radius. I'm going to use that formula. Now here's where, if you have a scientific calculator, most scientific calculators have a pi button somewhere built in. I have no idea if an iPhone does. Oh, I'm gonna do this. I don't know if you can see, the iPhone has a pi button down there. I assume an Android would as well. This is where some people differ. I would use the pi button exclusively. If you use and write out 3.14 or whatever, it's not that it's wrong. It's just not. It's not as correct as possible. But I'm not going to penalize you if you just write and use. If you use pi equals 3, I will straight up mark you wrong, because pi does not equal 3, unless you were in I think it was Indiana for a period of a number of years. In the 1800s, they decided pi was 3, and it caused all sorts of trouble. So 2 pi times 4, meters. I'm going to pull out my handy-dandy calculator. 2 times. I'm going to push my pi button. It's going to give me all those decimal places. Awesome. Times 4 equals. And then we're going to round it to 2 decimal places at the end. 25.13 meters. Now, I'm just curious if I use how far off will we be? Because it's something 2 times 3.14 times 4. Like you're off by 100th. Like I said, you're not wrong, but that's more, a little bit better. 2 times AP times 4, 25.1327, and it depends on what you're doing and all of that. If you get into higher level math courses, physics courses, engineering, you want to make sure you use as much as possible. So let's look at one. This one we're given a diameter. Could you turn that into a radius and use 2 pi r? Yep. But then doing that, you're doing an extra step, and then you're going to multiply it by 2 again. Eventually, most of these I'm going to give you are like going to be numbers where you're going to have, well, they're always going to be rational, so you're going to have a terminating decimal because you're divided by 2, so it's not going to make a whole lot of difference. Pi, that's centimeters. Pi times 6 equals 18.85. So those are some hopefully rather straightforward circles. And with no feedback, this is tough. Hopefully we are ready to go on. So we have these 2 super fun things to look at. And then down here, we'll find the circumference. Those are just, and then there's some extra practice. Well, that's a rectangle, the perimeter of a rectangle, circumference. So you've got to draw some shapes yourself in the end. But what we have here is a semicircle. Which is essentially half a circle. It's not essentially, it is half of. So if I want to find the perimeter, can I clone? Yeah, the numbers are going to be, well, that's not going to work out all that well. But I have half of a circle. But we also have, so can we find the circumference of half a circle given the diameter? Well, sorry, just a sec. Diameter is 7. So the circumference of a circle is pi times the diameter. The circumference, or, oh no, I know what I want to do. Let's see if the highlighter sometimes is a little bit sketchy because it's going to try to make this a straight line probably. So if I want to find that horrifically highlighted green length, that's half of a circle. So it's half of the circumference. So we can do that. So this is just pi times 7 meters divided by 2. Pi times 7 gives me that, divided by 2, 10.99557. That's 11 if we round it properly. But is that the perimeter of that whole shape? Nope, because what have we forgot or not done? We haven't added that part. Well, in this case, I need to just add 7 meters, and that one would have a perimeter of 18 meters. Sneaky, sneaky stuff. I don't even know if I can. Oh, I can do that. Now I could be, what's the perimeter of the speech bubble? Not a valid question. Probably requires university level math. But an ellipse. I assume there's a formula for it, but I don't know it off the top of my head. Would have to do with how long the major and the minor axes are. Again, something you don't have to worry about. Google is a wonderful tool. So, perimeter of a semicircle. Oh my gosh. Now I have, like, I don't know, it looks like the top view of a ginormous hot dog. But we want to find the perimeter of this whole weird and ugly thing. Oh, because it's a fun color. That to me looks like half a circle. Is this the other half of the circle? Oh, it's really hard. So to me, that looks like a whole circle. We also have to assume that they're symmetric because there's no other information given. Pen. So we have to find the circumference of that when we have from a center to this, we have a radius of 16 meters. Then, well, let's do this part first. Because it's a radius, we'll do 2 pi r 2 pi times 16. It's 32 pi's. Pi. Oh, 2 times pi times 16 is 100.53. Every time I think about pies, a few years ago on Mother's Day, my mother-in-law, we said, well, what do you want for dessert? And she said a cherry pie. And their 3 daughters and husbands, boyfriends at the time were like, seriously, a cherry pie? None of us had ever actually heard of a cherry pie, even though it's part of a song from the 80s. So we were all confused, and she got some other type of pie for Mother's Day dessert. And then it was actually in Sussex. I went over to Dunster's one day, either in the morning to get lunch or lunch to get lunch, and what was sitting on the counter at Dunster's was a cherry pie. So we had to take a picture of it. I asked her if she wanted it, and she said no. But now, like after she brought it up, and I'd never seen one for years, all of a sudden we started to see cherry pies. Sorry for my randomness, but it's still an entertaining bit to me. So we have 100 meters there, but then we have these two great big long stick parts. To find the perimeter, we're going to have to add that, which is kind of like part of a rectangle. But there's two of them at 65 meters each. That's 120, and that's 130 meters. So we can piece different shapes together. The questions, let's let people give everyone a second. If they need to write things down or are writing things down. So that's kind of it for circles. We'll go back. So we have find the circumference of some circles. Wow, that one's boring. But we've got some perimeter of a rectangle. Rectangle is the length and width. Find the perimeter of the rectangle. Any one of these down here. The first thing you should do, make a sketch. So I have this super awesome advantage. If I'm looking at 15, it doesn't have to be to scale. There's a rectangle. It says it has a length of 4 inches and a width of 5 inches. Well, what do I know about this? Well, if that's 5, that's 5. If this is 4, that's 4. And we can find the perimeter. You can do those as decimals. Circumference of a circle that has a radius of, circumference of a circle that has a diameter of. So those ones are all circles. A radius of 6 feet. And like make a sketch like that. I'm not going to go too far in depth with any more of these. But that's kind of it for today. Hopefully, oh, what's this? I'm not sure what's going on here. Some pie, I want some. Oh dear, I just noticed this. I'll read it later. No, Morgan, these are ones that we don't have. I didn't. Whoa. So, yeah, these ones we don't have. You can print them if you have a printer. I wonder if that's telling me there's chat activity going on. Unfortunately, we don't have these. If you have a printer, you can print them. I will print copies of all of this when we get back to school. So hopefully perimeter and circumference. Tomorrow we're going to look at the next one. Oh, why I'm in there. Tomorrow we're going to look at area. So on Teams, and I'll kind of link it. There's a blank copy of tomorrow. No, not tomorrow. Tomorrow is Saturday, and a lot of you probably will be asleep at 9 o'clock in the morning. Area is a multiplication. I don't know why this is being silly, but you will be given formulas, side squared, length times width, base times height, all of that sort of stuff. And we'll go through some examples, and then there's some practice to do. But if you have a printer, you can print them. If not, you can kind of sketch them, follow along, and that sort of stuff. Okay, let's just stop, everybody. I don't know how to shut a chat down, but if I have to, I will. Whoa, let's calm down, everybody. I need to turn it off. I don't know how to turn that off, but if I have to, I will. I don't know. That's something to see. So, where were we? The rest of that page is what we need to try for practice between now and Monday. Is there any questions? Just be nice. This is not the easiest thing in the world to deal with. But everything will be here. If you're missing stuff or whatnot, when we get back to school, hopefully sooner rather than later, we will go over some of this stuff again. And oh dear, let's everybody stop typing in the chat. So if there are no questions, give some of those things done, and have a good weekend. Hopefully it's warmer than -2 later on today. So you are free to go. Get some stuff done. Oh, wait. I need to do this first. Even if you've left. There, good.